So now we are going to go for polynomial fitting. Okay, so we are going to go for polynomial fitting. So why? What is the need for polynomial fitting is, so you have data from 1990 to 2015, right? So in case if I want to predict the data for the next 2 years, can I use this model to predict the data? For that, I'll be using polynomial fitting and polynomial evaluation functions for fitting and predicting data. Okay, that is the purpose I'm going to use. So you see polynomial fitting, you will be giving x comma y comma n. X is the number of locate data points. Independent means x-axis. So x is going to be your x-axis. Y is going to be the data which you want to fit into a polynomial, and n is the degree of the fitted polynomial. Assume you have x, and see this example, x and y. So x is varying from 0 to 5 and y is having these values. If you plot x and y, you're getting this one. So if you are going to fit a third degree polynomial to this, then you will get the coefficient of polynomial as c here. And how you write the equation? The p of x equal to minus 0.1296 into x cube, the third degree, plus 0.6865 into x square, minus 0.1759 into x, plus 1.6746 is going to be the constant. So highest degree, the lowest degree along with the sign. Okay. So if you want to evaluate the polynomial, use the function polynomial value and give the x fit and y fit. So you can easily plot the polynomial on the thing on a single window. This is your actual data and this is the fitted polynomial. Okay. So if you want to use the polyval, you have to use x fit comma y fit. The x fit is going to be from -1 to 6. The same range, whatever you have given 0 to 5, you can have the -1 to 6. And polynomial, the c, you have to pass the c because c contains the polynomial coefficients. If you pass the c along with x, you find out the y and you can plot both the things. Yeah, both the polynomial fitted data are not exactly same, but what they are saying is you can obtain a close fit between data and the polynomial. By increasing the order of the polynomial, you can add for some particular order of the polynomial, you can get a very close plot between the x and y values. Okay. So with the given polynomial, you can find for any x value what is the value of the y. That is possible. So that can be used in our example to find the value for the future values. Okay. Given 1 by 50 vectors x and y, what is the result of the above command? Polyfit of x comma y comma 3. So what is the result of the above command? Same is the answer. So what it will return? By A, B or C. So if I use polyfit command, what is the output Z? What will Z contain? 1 by 3 vector or 1 by 4 vector or 1 by 50 vector? I want the answers from you. 1 by 3 or 1 by 4 or 1 by 50. What vector you will get? When you use the polynomial fit function, return the coefficients of polynomial, right? So the order is 3. So the order is 3. So it will return x cube, x square, x and constant terms. So how many elements will be there inside the polynomial? You will have 4 elements. So we will try giving option B. Yes. Why option B? Because it's the third order polynomial. Third order means it will have coefficients for x cube, x square, x and constant. So it will have 4 elements.